second step is conversion or the reduction to the metals. This is the most important step in this in the metallurgy or in the extraction of metals is this step, the conversion or reduction. Actually, this step has been divided according to the different reactivity. If we talk about low reactive metals, least reactive metals like sodium and silver and gold. For these metals, you will see that what will happen. We will take this as what will happen. What we will do, we are going to use the sulfide ores of these metals and then roast it, roasting it, then refining. Okay, the last step is refining. Similarly, for the medium reactivity series for reactive metals, there are two different type of ores are found in nature: carbonates and sulfide. Okay, zinc sulfide, copper sulfide. Similarly, carbonate, zinc carbonate, and zinc carbonate and calcium carbonate. Okay. Similarly, for the highly reactive metals like sodium, potassium, magnesium, calcium. So what we are going to do? You are just only sodium पोटेशियम इलेक्ट्रोलिटिक रिडक्शन. दैट मीन्स इलेक्ट्रोलिटिक रिडक्शन भी आपको बताऊंगा. एक इलेक्ट्रोलिसिस करेंगे. ओके, उसमें आपके दो एनोड्स एंड कैथोड्स का यूज़ करेंगे और वहाँ पे जो मेटल है, प्योर मेटल, वो आपका एक्सट्रैक्ट हो जाएगा मेटल्स में. अब आप देखिए ये सेकंड स्टेप के अंदर रिडक्शन का मतलब क्या है. जो भी ओर है वो तो सल्फाइड होता है, सल्फाइड साल्ट होगा, सल्फाइड ओर होगा या फिर कार्बोनेट होगा या फिर कोई और. उन सबको आपको मेटल्स में चेंज करना है. तो जितने भी केमिकल रिएक्शंस होंगे वो इस स्टेज के अंदर होंगे. एंड द थर्ड स्टेप इज जस्ट रिफाइनिंग. रिफाइनिंग के अलग अलग स्टेप्स हैं. तीनों के अंदर आपको रिफाइनिंग करनी है, चाहे लीस्ट रिएक्टिव हो चाहे. ओके, सो द मोस्ट इम्पोर्टेंट इज जस्ट अबाउट द रिडक्शन टू द मेटल्स एंड द मोस्ट इम्पोर्टेंट अबाउट दिस टॉपिक्स इज द कार्बोनेट एंड सल्फाइड ores and what is calcination and roasting. So in the exam, which is most important topic, what the difference between calcination and roasting? As you must be knowing, there are 3 points of difference between them. Calcination is used only for carbonate ores. You have to remember it. Whereas for sulfide ores, you will use roasting. Okay. The second point of difference is obviously first I tell you it is used for carbon, it is for sulfide, and the second important difference is that the calcination is done in absence of oxygen. Okay. Whereas in roasting, presence of oxygen is required. So I am going to write the ratios. You will hear properly. For example, calcium carbonate. You can see what you have to do. Just simply decompose it. CO plus CO2. And here carbon dioxide gas is removed. You have to remember it properly. This is for calcination. Okay. In case of roasting, you can take the example of lead galena or zinc sulfide. Zinc sulfide is reacted in presence of oxygen. So what will happen? Zinc is removed and sulfur dioxide gases. Okay. So in this way it is reduced to zinc. Okay. Sulfur dioxide gas. So there are 3 points of difference. First, it is calcination is used for carbonate ores. Calcination and roasting is used for sulfide ores. Second, it is done in absence of oxygen. It is done in presence of oxygen. And the third point being that the end product gas is formed carbon dioxide, whereas in this sulfur dioxide gas is formed. You can give the example also. For example, you can take the example of carbonate ores, calcium carbonate. And similarly, you can take the example of lead galena or zinc sulfide or copper sulfide, copper purite. Okay, these are the main examples. So this is a very important topic, calcination, roasting and extractions. In the final extraction, the only thing you have to remember about first, the difference between electrolytic refining and electrolytic reduction. As I told you, you don't have to be confused. Electrolytic reduction means you are changing the oxides of these metals, that is sodium hydroxide, sodium oxides and potassium oxides, to their respective oxides. Okay. Whereas in electrolytic refining, you are going to refine, that you already have metals and you are going to purify these metals. Okay. So electrolytic refining, in refining you will just purify the metal, given metal. Whereas in the electrolytic reduction, you are going to convert their oxides or hydroxides to particularly sodium metal. Okay, as you know, the example of sodium hydroxide. Okay, you are going to electrolysis of sodium hydroxide, and sodium is formed. So very important topics covered here. One important property that I liked over the last topic was that the reaction of metals and non-metals, which are very important. As I told you, ionic compounds are formed. So what are the different properties of ionic compound? I am going to tell you. तुम कर लो. Hello. Okay. As I told you, it was about the topic we were talking was about the electrolytic refining. And before that, I am going to tell you about the metals plus non-metals. Because metals have a lot of electrons, a lot of free electrons, whereas non-metals don't have these, so they are going to readily complete transfer of electrons. Remember, if you are asked what are ionic compounds, you have to remember the reaction of metals and non-metals by the complete transfer of electrons are called ionic compounds. What are their important property? You have to know. They are ionic compounds, that is formed by the complete transfer of electrons. Okay. Then second, you have to remember that ions, as soon as you will add into water, you will see the electrons are removed. For example, NaCl. If you take the example of NaCl, you look, the metals are removed like this. Sodium ions are there. These are cations. These are anions. They will be shown as differently. So there is a lot of force of attraction between these two ions, that is positive ions and negative ions. So very good. A lot of force of attraction exists between these two ions, positive and negative ions. Third important property, they have very high melting points and boiling points. Very important to remember. Okay. Then fourth is that they have crystalline structure. Crystalline means actually the particles are just like crystals. Okay. You can see the pattern in the crystals, the shape of crystals will be there. And the fifth important property, very important, this also, that they do not conduct in electrolyte, but do not conduct in salt, do not conduct in solid state. Okay. Metals do not generally ionic compounds, what this property is about. You must know that ionic compounds they will conduct only in the electrolytic solution. That means when you are making the ionic solution, that means you are adding water to aqueous solution. You are adding water to it. जब तक वाटर में नहीं डालेंगे, अगर आप देखिए NaCl का एग्जाम्पल कॉमन साल्ट जो हम लेते हैं, it will not conduct in solid form if you take the example of salt. But if you take an example of salt solution and take put two electrodes in between them, and you will see that it is going to be pass the electric current, and you will see that it is a good current of electricity. So what you have to remember that electrolytic solutions or the ionic solutions, are a good conductor in only liquids or aqueous form. Okay, they will not conduct in solid form. This is very important property. And the last one, so this was about the ionic compounds, and the last topic that I am going to tell you about electrolytic refining. For example, you can take the example of this. How do we do this? Electrolytic refining, as I tell you, refining by the electrolysis method. Okay. So what will take the example of this? Suppose copper is extracted by these metals. Copper sulfate solution. Generally impure electrode is more thick, because, and this is called anode mud. How do we remember that which one is anode? This one is anode. the impure one. Okay, you apply the potential difference across this. Okay, so like this. Look here. In electrolytic refining, there are two, anode and cathode. Okay, the pure metal rod is called cathode, and the impure is called anode. And the anode mud is here. What will happen? The ions from copper, you don't have to remember much about it. Just remember it by looking at the diagram. Very important one. For in science, you just remember, if you know the diagram, then you can explain it properly. So you have to learn whatever concepts with the help of diagrams. Okay, look at the diagram here. The metal ions from the copper ions from this atoms from this electrode actually transfer in this copper sulfate solution, and from there you will see the pure metal, that is in the pure copper ions will transfer here. Okay, and all the impurities will move here down the anode. That's why it is called anode mud. So you have to remember this properly. This is called electrolytic refining. In the exam, if it comes, you have to give the example of copper. Copper is activated by this method. Okay, very good topic for these exams. And one of the last topics is just about alloys. What are alloys? You have to remember, alloys are formed by the combination of metals within themselves. So what will happen? Like bronze, like brass. What is the difference between alloys, properties of alloys and metals? You just learn it by heart. In alloys, you just identify first thing that the properties of alloys are not the same as the original metals are, because for example, if you take the example of duralumin or magnalin. Okay, duralumin is an alloy of magnesium and aluminium. As you know, aluminium is very light metal, but there are some properties of aluminium which are not so good for making it in aircrafts. Okay, it is used in aircraft bodies and likewise or in the ships. The most important property of duralumin is that it is very light in nature, more even lighter than aluminum. At the same time, it is not going to be as so much conducting as in the air. You know, the temperatures may go very down or may go very up, but you have to make a constant temperature, and you have to make the weight minimum or the mass minimum. So you will use duralumin there. Okay, so what are alloys? Alloys have the properties very different from the original metals. Okay, similarly you can take the example of bronze, brass. Okay, or any other alloy. So I will tell you a list, or you can remember it by heart. What are the different alloys and what are the constituent metals in generally life? You have to just remember it. The next important being, I am going to tell you what is amalgam, because in the exam it is asked, 1 marks it can be asked. Amalgam is just whenever a metal is going to form an alloy with mercury, then it is called amalgam. So amalgam can be any metal. There can be any iron, there can be zinc. Whenever any metals is reacted, is going to form an alloy with mercury as one of the metal, then it is going to be called amalgam. For example, if zinc is added, then it is called zinc amalgam with mercury, zinc plus mercury. Tin is added, then tin amalgam, like this. So very important for the exams also. Can only asked in 1 or 2 marks. Okay, so it's what about the alloys. You just have to remember a list of all the alloys. I'm going to tell you the list, complete list of all these. Okay, as I told you, this was the list that you have to remember. Generally in stainless steel, carbon is used, then nickel, chromium are also added to make it further strong. So first brass, in brass copper and zinc are added in a particular ratio, generally 90-10%. Okay, 90 to 90-10. Then bronze, in bronze copper and lead, copper and tin is used. Okay, and then duralumin, aluminium plus magnesium. In solder, lead plus tin. Amalgam, as I told you, mercury. And then stainless steel, carbon is the compulsory. Then you can add nickel, chromium, and number of metals. In this, phosphorus is also sometimes added, and silicon also. And a number, sorry, not silicon, phosphorus and nitrogen we also added sometimes. Okay, so to make it further strong, there are different types. Just you have to remember the basic concept. So thank you friends for all of you for your support, and if you like this video, subscribe, and for more videos of this chapter, as I'm going to tell you in further, so you can ask, you can comment in the video also section also for any improvement further. Thank you guys.